Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 11 video on the topic of determination of density of liquids, where I will solve 5 multiple choice questions. This is set 1. This Solving these questions is based on the video part 10 where I discussed about the key concepts and formulas how we determine the density of a liquid using density bottle. So this topic is from the chapter of physical quantities and measurements, and the playlist is this is all about physics of class 8 of ICSE board, where in this playlist I primarily discuss the key concepts and formulas and solve problems. If you find this video beneficial, then please like it and share it with your friends. And if you want to further support me, then please subscribe to my channel. And in that case, please do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 11 video where I will solve 5 MCQ on determination of density of liquids using density bottle. Okay, so the first problem says that an empty density bottle weighs x gf gram force, which means that the mass of the empty density bottle is x gram. When filled completely with water at 4 degrees centigrade, it weighs y gf. Sorry, when filled completely with a liquid L of density rho gram per centimeter cube, the density bottle weighs z gram force. Then the value of x is. Okay, so from the concept of finding the density of a liquid using density bottle, what we can say, let's say the mass of the empty bottle be capital B. B is the mass of the empty bottle, which will be x gram. Since the weight of the empty bottle is given as xgf. Gf stands for gram force. So which is a force or weight acting on a body of mass x gram. Okay, so we have this. Also it says that the weight of the density bottle filled with water at 4 degrees centigrade is YGF. So M, capital M, B, W, capital M, BW means weight of the density bottle plus water at 4 degrees centigrade. Oh, sorry, not weight but mass. This will this will be Y gram. Okay. So we know that clearly the mass of the water will be M BW minus M B, which will be Y minus X gram is the mass of the water which is completely filling the density bottle. That is, the volume of the water is the volume of the density bottle. Okay. Now, when filled completely with the liquid L of density rho gram per centimeter cube, the density bottle weighs Z gram force. So let's say the mass of the liquid that is completely filling the density bottle is M L. So we have and also let's say MBL be the mass of the density bottle plus the liquid L. This is given as Z gram. So we have M, the mass of the liquid will be mass of the density mass of the density bottle, empty density bottle, mass of the density bottle completely filled with the liquid minus mass of the empty density bottle. This is Z minus X, this much gram. Okay. Now from the concept of finding the density of a liquid, we know that the density of the liquid L, which is already given in the problem as rho gram per centimeter cube, rho will be equal to the mass of the liquid completely filling the density bottle, which is Z minus X gram divided by the volume of the density bottle. The volume of the density bottle will be equal to the mass of the water at 4 degrees centigrade that is completely filling the density bottle, which is y minus x. Uh, so this is centimeter cube. Okay. So essentially, so rho is z minus x divided by y minus x. Okay. The problem has asked the value of x. So this is a linear equation in x, and we can easily solve it. If I do cross multiplication, I get z minus x is equal to rho into y minus x. This implies if I bring all the x terms to the left hand side and all the other terms to the right hand side, I get minus x plus rho x is equal to rho y minus z. If I take x common from the left hand side, I have x multiplied by rho minus 1 is equal to rho y minus z. This implies x is equal to rho y minus z divided by rho minus 1. Rho minus 1. Remember, this will have no unit, x will have no unit, because it was given that the empty density bottle weighs x gf. So x is merely a number, it's a real constant, real value. So the value of x is rho y minus z divided by divided by rho minus 1. So clearly the correct answer is B. B is the correct choice. Now, if I am doing any kind of mistakes in applying the formula or concept, or doing any kind of silly mistake, or doing mistake in with the units, then please do let me know in the comment section. Please feel free to let me know all these issues, or if you have any kind of query, clarification on any concept or steps, then please feel free to let me know in the comment section. I will highly appreciate that. Okay, let's do the next problem. A liquid L has a density which is denoted by rho L, which is P times that of density of water at 4 degree centigrade. Okay. An empty density bottle weighs capital P kgf and it weighs capital Q kgf when filled with the liquid L. So the weight of the empty density bottle is capital P kgf. So we can say that the mass of the empty density bottle will be P kilogram. And it is given that the the weight of the density bottle filled with the liquid L is Q kilogram. So MBL, well, where MBL is stands for the mass of the density bottle completely filled with the liquid L, is given as Q kilogram. Okay. So clearly the mass of the liquid that is completely filling the density bottle will be Q will be MBL minus MB, which is equal to Q minus P this much kilogram. Okay. Also, it is said that it is given that the density rho L is P times that of density of water at 4 degrees centigrade. I know that the density of water is 1 gram at 4 degrees centigrade is 1 gram per centimeter cube. So obviously the density of the liquid rho L will be x gram per centimeter cube, since it is given the density is P times that of density of water at 4 degrees centigrade. Okay. What else? If capacity of the density bottle is VML and capacity of the density bottle is VML, okay, so the volume of the density bottle is given as VML, which is V centimeter cube. Now clearly, since we are using water at 4 degrees centigrade, we can clearly say that what is the weight of the density bottle completely filled with water is not given. The relative density of the liquid is Z. Okay. The density is given to be T times that of water at 4 degrees centigrade. Also, it is given that the relative density of the liquid L is Z. Now, a relative density of the liquid L is given to be Z. This clearly says, we can say from here that the density of the liquid L will be Z gram per centimeter cube. Now we also we have got earlier that PL rho L is x gram per centimeter cube. So clearly we can say, rho L is not x gram per centimeter cube, it will be T, because it is given the density is T times the density of the liquid L is T times that of density of water at 4 degrees centigrade. Sorry, this will be T. So rho L is T gram per centimeter cube, also rho L is Z gram per centimeter cube. So clearly Z will be equal to T. Z will be equal to T. So now we can, in the given choices, we can see that Z equals to T is only provided in choice C and D. So definitely one of choices D or D, one of the choices C or D will be correct. Now we have to find what will be V. That is the capacity of the density bottle is given as VML. We have to find V. How do we know V? How do we know V? How do we know V? Okay. If capacity of the density bottle is VML, to find the capacity of the VML, either we have to know, we need to know the weight of the density bottle completely filled with water at T degrees centigrade, at 4 degrees centigrade, or we need to know that. Otherwise, we need to know the mass of the liquid L that is completely filling the density bottle. The mass of the liquid is, okay. So the mass of the liquid is Q minus P kilogram. This is equal to, let's convert the kilogram to gram. This will be Q minus P multiplied by 10 to the power 3 gram. So we know the mass of the liquid inside the density bottle is Q minus P multiplied by 10 to the power 3 gram. Also we know the density of the liquid is T gram per centimeter cube. So clearly the volume of the liquid which is inside the density bottle is equal to the capacity of the density bottle, which is given as VML. So we can say that V is nothing but ml, mass of the liquid, divided by its density, which is equal to Q minus P multiplied by 10 to the power 3 gram divided by what was rho L. Rho L was T gram per centimeter cube. Okay, so this becomes Q minus P into 10 to the power 3 divided by T, this much centimeter cube, which is also equal to ml. 1 centimeter cube is equal to 1 ml. So V is Q minus P whole multiplied by 10 to the power 3 by T, which is 1000 Q minus P divided by T ml. So definitely from the between the choice C and D, we can clearly see that the correct choice is C. C is the correct choice. My as you can see, my solution is very congested. I am really sorry for that, but I hope I am able to properly explain the concept that I am applying while solving the problem. Still, if you need any kind of clarification, or if you have any query regarding any step please feel free to let me know in the comment section. My internet is off. Bye. Okay, let's see the next problem. Question number 3. The density of a liquid A relative to the density of liquid B is capital R. An empty density bottle weighs W1 gram force. When the bottle is filled with water at 4 degrees centigrade, it weighs W2 gram force. When the bottle is filled with liquid B, it weighs W3 gram force. Sorry, then the density of the liquid A in gram per centimeter cube is. Okay. First of all, let's consider rho A to be the density of liquid A and rho B to be the density of liquid B. So it is given that density of liquid A relative to the density of liquid B, which is rho A divided by rho B. This is the ratio of density of A with the density of B is mathematically termed as density of A relative to density of B. So this is given as R. Ultimately, we have to find the density of liquid A. Okay, so this implies we have rho B. Let's find rho B in terms of rho A. No, we have to find the density of liquid A. Okay, so it will be better if we find rho A in terms of rho B. So rho A will be R into rho B. Okay, this is one relation we got. What else? An empty density bottle weighs W1 GF, which means its mass of empty density bottle is W1 gram. Also, the mass of the density bottle filled with water at 4 degrees centigrade is W2 gram. So clearly, the mass of water in the density bottle or the mass of water having a volume equal to the density bottle at 4 degrees centigrade will be W2 minus W1 this much gram. This implies that the volume of the density bottle will be equal to, we can say, W2 minus W1 centimeter cube. Since we know the density of water at 4 degrees centigrade is 1 gram per centimeter cube, so W2 minus W1 gram of water at 4 degrees centigrade will have a volume of W2 minus W1 centimeter cube. Okay. Now, it is also given when the bottle is filled with liquid B, it weighs W3 gram force, which means that the mass of the liquid B having a volume equal to the volume of the density bottle is equal to W3 minus W1. This much gram is the mass of the liquid B that is completely filling the density bottle. So we can say that the density of the liquid B will then be equal to MB divided by the volume of the density bottle or the capacity of the density bottle, which is V. This will be equal to W3 minus W1 divided by W2 minus W1, this much gram per centimeter cube. This is the density of liquid B. Okay. So clearly, the density of liquid A we know is R into rho B, which will be equal to R multiplied by rho B, which we got as W3 minus W1 divided by W2 minus W1. This much gram per centimeter cube should be the density of liquid A. So, sorry. So the correct choice is choice D. D is the correct choice. Okay, let's see the next problem. Question number 4. The relative density of warm water, which is at 20 degrees centigrade, is X. Relative density of warm water, the warm water is 20 degrees centigrade is X. The density of a liquid L with a density bottle was determined to be rho 1 gram per centimeter cube and rho 2 gram per centimeter cube respectively, using water at 4 degrees centigrade and warm water. Okay, then the value of the ratio rho 1 is to rho 2 is. So it is saying that the density of the liquid L was determined once with the density bottle, once using water at 4 degrees centigrade, and the second time using water at warm water, which is water at 20 degrees centigrade, where we know that the density of water, which is denoting with rho W at 4 degrees centigrade, we know is 1 gram per centimeter cube. And let's say the density of the warm water WW, the relative density of warm water is X, which means that the density of the warm water will be X gram per centimeter cube. Okay. Now, when the density of the liquid L was determined using water at 4 degrees centigrade, so water at 4 degrees centigrade, the density of the liquid was rho 1. Okay, rho 1 gram per centimeter cube, and so for water at 4 degrees centigrade, the density of the liquid L is found to be this, and for water using water at 20 degrees centigrade, the density of the liquid was found to be rho 2 gram per centimeter cube. So it is now asking the ratio of rho 1 is to rho 2. Now the question is, will the density, will we get a different value of density for the liquid? See, the liquid L is same with the liquid. For the liquid L, if we are using water at 4 degrees centigrade once to find the density with the density bottle, and if we use water at 20 degrees centigrade to find the density. No, the density of the liquid, since we are measuring the density of the same liquid, the density of the liquid will not change. It will not change until and unless for a certain, as you can see, it is the same liquid, and the volume of the density bottle is same. It will be its capacity is same, so its volume is same. So, and since its volume is same and the same liquid L is used, quite obviously the fundamental concept is that we are not heating or cooling the density of the liquid L. The density of a liquid L will only change if for a certain mass of the liquid L we change its volume. But since we are using the same liquid and the value, the density will not change. Rho 1 and rho 2 will be same. Now the thing to understand is that so we know that for in general the density of the liquid L using a density bottle, we know the density, the formula of the liquid L is mass of the density bottle plus the liquid minus the mass of the bottle, empty bottle, divided by the mass of the density bottle completely filled with water at 4 degrees centigrade minus the mass of the empty bottle. Now, clearly the mass of the empty bottle is not changing, it is same. MBL will change. MBL will be quite obviously MBW the core concept is that since the liquid L is same, MB is not changing. The density of the empty bottle is not changing. And also, since the volume of the density bottle is same, V is same, the mass of the liquid L that is filling the density bottle in both the cases will be same. That is when in the first experiment we are using water at 4 degrees centigrade, and in the second experiment we are using water at 20 degrees centigrade. Now, in both the cases, the mass of the liquid L completely filling the density bottle will be same. So this part is same. This part is same for both the experiment. Let's say in the first experiment we are using water at 4 degrees centigrade, and in the second experiment we are using water at 20 degrees centigrade. This part MBL minus MB will be same. The difference will come in the denominator, MBW minus MB. Actually, the difference will come in MBW, that is the mass of the density bottle plus along with the mass of the water. That is first time at 4 degrees centigrade and the second time at 20 degrees centigrade. Now, since whether we are using water at 4 degrees centigrade or we are using water at 20 degrees centigrade, the capacity of the density bottle, that is the volume of the density bottle, is not changing. We consider V to be the density of to be the capacity of the density bottle, or the volume of the density bottle, or the volume of the water at 4 degrees centigrade or 20 degrees centigrade, and the volume of the liquid L. Since V is not changing, essentially V is not changing, so the rho L, this is nothing but MBL minus MB. Basically the formula was MBL minus MB divided by V, that is V is the volume of the density bottle or capacity of the density bottle, which is also will be equal to the volume of the liquid L or the volume of water at 4 degrees centigrade or 20 degrees centigrade. So in this whole formula of density of rho L, that is the density of the liquid L, since the mass of the liquid L is not changing, also the volume of the density bottle is not changing, the density in both the cases will be same. So clearly rho 1 has to be equal to rho 2. So the ratio rho 1 is to rho 2 should be equal to 1 is to 1. So basically this is a little conceptual problem to confuse students, bringing the factor of warm water having a density which is different from water at 4 degrees centigrade. I hope you understood the concept why in both rho 1 will be equal to rho 2, because the main concept is that we are using the same liquid. The liquid L is not changing. So if a liquid L is not changing, whether you use and we are using a density bottle of a certain capacity, the volume of the density bottle will be same. Now, so the core idea is to find the volume. So, and the mass of the liquid filling the density bottle. So as long as the mass of the liquid L filling the density bottle is same, and of course the volume of the density bottle is same in both the experiment, the density of the liquid will be same. I hope I was able to properly solve this problem with the correct way of explanation. Okay, let's see the next problem. An empty density bottle has a mass of m gram. Okay, when filled with the liquid A, the bottle weighs ma gram force. Okay, when filled with liquid L, the bottle weighs ml gram force. Find the density of liquid L if the relative density of liquid A is R. So basically in this case, instead of water at 4 degrees centigrade, it is using another liquid A, whose relative density is given to be R. Now relative density of liquid L is equal to R implies that the relative density of liquid not L but A. Relative density of liquid A is given to be R. This implies the density of the liquid A is nothing but R gram per centimeter cube. Okay, so we know the density of the liquid A. Fine. Okay. Okay. Also, it is given that the mass of the empty density bottle is m small m gram. So, using our notation, mb is m gram. Also, the weight of the liquid A with the density bottle is MaGF. So, MBA means the weight of the density, the mass of the density bottle completely filled with liquid A. It should be M. It is this should be MB plus the mass of liquid A, that is completely filling the density bottle. This implies that the mass of the liquid A that is completely filling the density bottle is MBA minus MB this much gram. Okay, we know the mass of the liquid A which is completely filling the density bottle, which is MBA minus MB gram. This is equal to what is MBA? MBA is mass of the density bottle plus the liquid A, which is given as small ma. So this is small ma. This is small ma. So this will be ma minus what is MBM, this much gram. Okay. So the mass of the liquid A completely filling the density bottle is ma minus n gram. Fine. And also the density of the liquid A is R gram per centimeter cube. So definitely the volume of the density bottle will be Ma divided by rho A, which is equal to small ma minus m divided by R. This much centimeter cube should be the volume of the density bottle, which should also be the volume of the liquid A filling the density, liquid L filling the density bottle. Okay. Now it is also given that when the when the density bottle is completely filled with liquid L, it weighs mlGF. So m BL, which is the mass of the density bottle plus the liquid L, will be m mass of the empty bottle plus the mass of the liquid L, which is completely filling the density bottle. This is given to be small ml gram. So this implies that uh, ml is equal to ml minus mb this much gram, which is equal to ml minus mb is m this much gram. So the mass of the liquid completely filling the density bottle is ml minus m gram. What was the question about? Find the density of the liquid L. Okay, so we have to find the density of the liquid L. That we have found that the mass of the liquid L completely filling the density bottle is ml minus m gram. Also we know, now we need to know the volume of the density bottle, which we know is ma minus m by r. So we can say density of the liquid L is nothing but ml divided by v, which is equal to ml is small ml minus m, this divided by ma minus m divided by r, this much gram per centimeter cube. This is equal to, after simplification, r multiplied by small ml minus m divided by ma minus m, this much gram per centimeter cube should be the density of the liquid L. Let's see the choices. The first two choices are given in gram per centimeter cube. Choice A is definitely incorrect because choice A is not having the factor of R. Choice B is the value is same, but it is given in kilogram per meter cube. So definitely A and B are incorrect. Let's see, choice D is incorrect because the factor R is in the denominator. In the answer, we have got the R is in the numerator. So quite obviously, choice C should be correct. Let's verify. So we are having we got the density in gram per centimeter cube. If we want to convert this to kilogram per meter cube, this will be nothing but we have to multiply with 10 to the power 3. So this is 10 to the power 3 multiplied by R m L minus m divided by ma minus m, this much kilogram per meter cube. This is the density of the liquid L in SI unit. So the correct choice is choice C. C is the correct choice. So with this, it comes to an end in solving 5 multiple choice questions on the topic of determination of liquids, determination of density of liquids with the density bottle. I don't think whether I will be able to frame more questions. I will try. If I can, then I will make another set 2 of 5 multiple choice questions. That will be the next video. If not, then I will move on to the next topic, which is about laws of flotation, that is floating and sinking of a solid in a liquid, which is a very interesting topic, having a good and needs a clarity of good concepts to solve the problems. Okay, so if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel. And in that case, please do not forget to press the bell icon so that you will be notified by my future videos. So that is all for this video. Stay tuned for the upcoming videos. And so thanks for watching, and until the next video, take care and bye.